Hello Yuri. Title of project assigned to our team is Design Cost-Effective Business Solution with Good Use of Technology for Eco-Friendly Design of Residential Apartment Buildings. Our team consists of two members, myself Sanket Patil from JSPM College Pune and my friend Yogesh Dembe from VESIT Mumbai. Our business solution consists of four parts. The main areas include to make residential building pollution free, to make residential building eco-friendly, and to save water. Requirements: reduce global warming and putting a step ahead towards a greater future for next generation. Reduce pollution, promote green lifestyle. Legal compliance: is solar panel installation allowed in given premises? What all permissions do we need from government to undertake this project? Do we need any inspection from government before or after the implementation of the project? Our proposed solution consists of four models: air quality monitoring system, waste management system, water management system, and hydraulic elevator control subsystem. There are many issues related to water purity around the globe. There are standards set by WHO for potable water which are followed at the source side, but they are not verified at the destination side. During transportation of water from source to destination, many contaminants get added to the water. So in this project, we are concentrating on the basic characteristics which identifies that the given water is safe to drink. The basic characteristics is potable water must be crystal clear. It should not have any muddy substances or impurity. We are monitoring the turbidity of water, and based on the turbidity level, the user is not notified whether the water is safe to drink or not. To detect suspended particles, we are using light source and photodiode. As the suspended particles pass through water, intensity of light source falling on photodiode changes and it can be detected. Further, this voltage level can be amplified by 3 ampere OP and can be further modified to make it compatible with microcontroller. The display device is used to perform analysis of the data received and convert the data into user understandable form and display the final result. Air quality monitoring system. Gas sensor provides alerts when hazardous gas is present in the surrounding environment. The sensor has wide operating range, fast response, and high sensitivity. It can provide analog as well as digital signals. It operates on plus 5-volt supply. This sensor can be used to detect carbon dioxide, ammonia, nitrogen oxides, alcohol, benzene, smoke. Detecting concentration scope: 10 ppm, 300 ppm NH3, 10 ppm to 1000 ppm benzene, 10 to 300 ppm alcohol. Our proposed solution consists of designing and implementing intelligent garbage bin for monitoring, segregating and decomposing of waste. Basic objective of the product is to detect the garbage level of bin. After detection of garbage level, if it reaches critical level of overflow, the message should be sent to the respective person. If the garbage not collected, it should be dropped down into decomposition box. After decomposition of the waste, the non-decomposable and decomposable waste should be collected in their respective bins. The gas produced during the decomposition of the waste should be compressed and stored into storage tank. The collected gas should be processed to generate electricity. Also, while decomposing the waste, if done in anaerobic conditions using methanogen agents, it can produce a good amount methane gas, which then further can be compressed and burned, and the heat generated can be provided to the pelleter cooler sensor, which will generate electricity. This energy can be stored and used for the bin itself, and the excess can be provided to the other electrical devices in the vicinity. Also, we can provide ML to the software application so that we can provide dynamic route selection the collector, and also we can predict the usage of bins, which can help the collector to know when he has to collect from the bin again. A hydraulic lift is a type of machine that uses a hydraulic apparatus to lift or move objects using the force created when pressure is exerted on liquid in piston. Force then produces lift and work. Function. Hydraulic lift technology has a multimedia of industrial applications like construction and transport. It is often implemented to operate heavy machinery or to move and lift heavy and large objects like cars, dirt, and shipping containers. Physics. One of the physics equations that applies to hydraulic lift technology is pressure into area equals to force. This helps determine the pressure exertion required on a liquid in a piston to produce enough force to provide lift and move an object. Significance. Hydraulic lift technology is a critical aspect of engineering, without which many applications will not be possible unless another technology existed to replace it. Automotive construction, agencies, and shipping industries depend heavily upon it, and it has contributed to a large part of the modern world as we know it. Fun fact: even automobile brakes uses hydraulics. When you push the brake pedal, it pushes a small piston in the brake master cylinder. The piston applies pressure on the brake fluid, which transfers the pressure through the brake lines, forcing another set of pistons to force the brake linings into contact with the brake drums on each wheel. The resulting friction of brake lining against the brake drum slows the car down, eventually stopping the car. Cool roof technology objective. The objective to use cool roof technology is to set up cool roof at low cost to bring back the traditional approach in modern way. Scope to reduce the effect of urbanization heat, to introduce the concept of cooling using earthen pots. Step 1. Step 1 is surface preparation. First, clean the surface. Wash the surface thoroughly with water. Step 2. Step 2 is waterproofing treatment of roof surface. First, apply the first coat of cement-based waterproofing chemical. Then lay fiberglass mesh fabric sheet over the first coat of waterproofing sheet. Third is apply the second coat of cement-based waterproofing chemical over the fiberglass sheet. Then apply the third coat of cement-based waterproofing chemical over the second coat. And after all this, allow it cement coat layer to dry for up to 24 hours. Step 3. Step 3 is application of inverted earthen pots option. First, lay cement slurry over waterproofing layer. After that, lay inverted earthen pots over cement slurry. Then lay 25 mm thick cement layer between earthen pots. Then after that allow it cement slurry to dry up to 24 hours. After that apply another layer of 50 mm thick IPS over the cement layer and finish the surface using aluminum script. Then lay 25 mm thick layer of cement over IPS layer and smoothen the surface using aluminum screed. After that, break the ceramic tiles into small pieces. Lay another layer of cement slurry on it. Lay broken ceramic tiles over the cement slurry and at the end lay white cement slurry over it to fill the joints between ceramic tiles. After all this, it will result up to 1.5 to 2 degrees Celsius temperature difference between indoor and outdoor temperature.